Well, we like to work with linear functions and constant functions because they're easy to graph. We can also work with any function as part of a piecewise function. We're going to mostly restrict ourselves with working with easy-to-graph functions like basic quadratics, in this course anyway. Later on, you'll encounter piecewise functions that involve all sorts of outlandish things. So in this example, we notice that one of the pieces of our function is quadratic. But we're really going to proceed with this graph in very much the same way that we did the piecewise linear function, except that when we go to graph that part, we're going to have to graph a parabola, right? That's a quadratic, its graph is a parabola. So we'll start exactly the same way that we did before, by cutting our graph into strips. The first piece of our domain has x less than -1. So our first cut is going to be made at -1. And this is going to be piece number 1. So in piece number 1, we have x less than -1, and f of x is x plus 3. Our next strip is going to run from -1 up to 2, so we'll make a cut at 2. And I'm going to leave myself 2 spaces here. Piece number 2 runs from -1 to 2, and that uses our quadratic piece. And to graph a quadratic, we need the vertex and 2 points. So I'm actually going to leave myself 3 spaces there. Our third piece includes all the values greater than or equal to 2. So our third piece is the whole rest of the graph, and we'll make a note of that here. That's for x is greater than or equal to 2, and on that piece, f of x equals -1. Okay, how do we graph this? On the first piece, our function is linear. So we need 2 points in order to graph that. I'll use the endpoint for one of them, plugging -1 into this expression. One of our points will be -1, 2. Now, x is less than -1. We only have one endpoint there. We need a second number, and we can pick any number we like as long as it's less than -1. I'll just typically pick the next number, unless I have a fraction that I'm trying to deal with. I'll just take f of, the next number is -2. So I'll have -2 plus 3 is 1. My next point is -2, 1. I could have picked any number. I could have picked -3 or -4, for example. Now, in this piece of the graph, x is not allowed to equal -1. So this point is out. I'll put an open dot at -1, 2. X is -2, that's just an ordinary point in my region, so I'm just going to put an ordinary point at -2, 1. That isn't the filled-in dot that I use to show my endpoints. It's just an ordinary point on my line. And the only reason that I had to draw that is that now I'm going to draw a line through those points. And I notice that this continues on off to the left of the graph. So I'm going to add an arrow onto the end of that. Okay, So that's that piece done. Next piece. This is my quadratic piece. If I want to graph a quadratic, the first thing I do is to think of the vertex. I could also do this by transformations, but in this setting, using the vertex is easier. Of course, it actually amounts to the same thing. My vertex here, I have x minus 1, so the x-coordinate of my vertex will be 1. And then I have minus 2 outside the parentheses, so the y-coordinate of my vertex will be negative 2. I'll put an ordinary point again at 1, negative 2. That's going to be the vertex of my parabola, which is going to open upward. Okay, now to draw a parabola, I need a point on either side. I might as well use, for my points on either side, the endpoints of my region, so that I know where my ends are. So now I'm going to plug in the negative 1 and the 2 to see where the ends of that part are going to be. So I'll take f of negative 1 is negative 1 minus 1 squared minus 2, and that works out to positive 2. So one of my points is going to be negative 1, 2. F of 2, that'll be 2 minus 1 squared minus 1 is negative 1. My second point is going to be 2, negative 1. Okay, and then x is allowed to equal negative 1, so this point is in. X is not allowed to equal 2, so this point is out. I'll put a filled-in circle at negative 1, 2. I already had an empty circle there, but if I have both an empty circle and a filled-in circle, that's a point on the graph. I definitely want a filled-in circle there. It doesn't matter that this is the one I'm making second. Filled-in circles always take precedence over empty circles. Okay, and then at 2, negative 1, I'll have an empty circle. And then I will draw a parabola through those points with that vertex that I found. No problem. Okay. Third piece. My third piece is a constant. This is going to be a horizontal line at y equals negative 1. Constant functions, their graphs are always horizontal lines. And at the boundary, at x equals 2, I'll have the point 2, negative 1. What kind of dot does that get? Well, x is allowed to equal 2, so I'll have a filled dot there. 2, negative 1. I already have an empty dot there, but the filled-in dot takes precedence. Horizontal line, extending to the edge of my graph and beyond, because I'm including all of the x's that are greater than or equal to 2 on that part of the graph. So this was just the same as the previous problem, except that one of our functions was not linear, which is just a thing that's allowed to happen in piecewise functions.